important is to identify the highest and the lowest point, which we call, of course, extreme values, absolute extreme values. But what's happened, we know that sometimes function doesn't have it. Like, for example, when we will take x squared, oh, it should sit here. Does this function has like the the highest point? Of course not. Yeah? Or not even mentioning about the x cube. Oh, my pen is not even the lowest point. Okay, but what we have, I mean, in general, for some application that you will be applying somewhere, I don't know, in your science class, engineering, IT, I mean, anything. Sometimes we like to, if we have some model, some function, we would like to identify the highest and the lowest point. Yeah, like the absolutely highest value and absolutely lowest value. And we can see if the model is x squared, x cubed, no highest point, no lowest point for the x cube. But what we will do in this case, we will kind of like restrict the domain. Okay, and then let's even see here. If we will take this function, I will draw it properly, and I will just define this function from -1 to 2. Yeah, just this part. Right? That's first of all, function must be continuous function. Yeah, we have to have continuity, and then we defining this function on the closed interval, x squared on the interval from -1 to 2. Do you think we can say the highest and the lowest point now? What is the absolute maximum? Oh, who can tell me absolute maximum for the function x squared? Is that dot, right? What is this question mark? Oh, you definitely know. Value of x squared at 2. Oh, come on, you have to tell me.
4.
4. Thank you, Jason. I think that's Jason, right? Thank you. Okay, value of the function at 2, 4 is the highest point. What about absolute minimum?
Still 0?
Actually, yes, actually it's 0. Okay, but we can see, we can definitely identify as soon as we have continuous function and I will kind of like locked, I will restrict the domain, then it's no question, we will always find the highest and the lowest point. However, what's happened from the calculus point of view? It just happened that one of these extreme values, maximum in this case, actually happened at that endpoint, at 2. Okay, f of 2, 4. But absolutely lowest point, it actually fell on the locally lowest point. It's okay, it's still fine, but it's locally. The endpoints, -1 and 2, has nothing to do with this minimum value, absolute minimum value. But okay, that we can learn from this and we can make the conclusion. If I will restrict the domain, and if we're looking for the extreme values, the values could happen at the endpoints or at the critical points, because 0 is a critical point. We have horizontal tangent. And in order to find this highest and the lowest point, we have to find the value for endpoints. I can also find the value for -1. -1 squared, it is 1. Okay, and this one is 4. But of course, 1, 0, and 4. Of course, 4 is the highest, 0 is the lowest. That means the algorithm, the procedure is to find the values at the endpoints and also find all of the critical points and also find the corresponding value of the function. And then whichever is the highest will be the maximum, whichever is the lowest will be the minimum. Let's see, this is the extreme value theorem. Important tool for some applications, and yeah, at the moment we're just looking. Okay, if f is continuous function, of course we can't afford any discontinuity, gaps, asymptote, jumps. No, if f is continuous functions on the closed interval from a to b, then always f attains the absolute maximum at the certain number C and absolute minimum at the certain number D, and C and D, of course, are inside that interval. And we can see it could happen here, C and D, critical points. C is critical point here, but the lowest number actually is at the end point. And, oh, okay, my graphs maybe are not critical point, critical point, critical point, not the end points. But this one, we can see this one is the end point. Yeah. End point is giving us absolute minimum. And this one is a critical point. Critical point. And it's giving us absolutely highest point, maximum. Okay. I have just an example that if we're not satisfying all of the condition for this theorem, we can't conclude, we can't like say this. If we have discontinuity, even if the interval is closed from 0 to 2, we do have discontinuity. And looking at this graph, do you think we can say what is the maximum, the absolute maximum value? Do we have maximum value? Not really, yes. We can see 3.
No.
3 is not even, we don't have value at 3. 2.9, 2.999, 2.999. No, we have no absolute maximum. We have absolute minimum, but that's not. And of course, the second example is showing that function is continuous function, but it's defined on the open interval. It's not closed interval. 0 doesn't have a value and 2 is an asymptote. In this case, doesn't have a value either. Okay, of course, continuity and closed interval. Okay, and I have just the steps, like the algorithm guideline, how to find the absolute maximum and minimum of the continuous function defined on the closed interval. We have to find critical numbers, okay, and then find the value of the function for the critical numbers. We have to find the value at the endpoints and just compare whichever is the largest, whichever is the smallest, absolute maximum, minimum, respectively. Let's see. Let's do it. Find the absolute maximum and minimum values of the function x cubed minus 3x squared plus 1. And the interval is from -½ to 4. And you can see I even get prepared. We have to find the value at -½ we have to find the value at 4. That's the endpoints. We also have to compute a critical points and find the corresponding value, whichever is the highest maximum, whichever is the lowest minimum. Yeah? Okay, shall we start with, let's substitute maybe. Oh, I don't know if I like to substitute this number, q, just using the formula of the function, of course. Yeah. 3 times -½ squared will be +1/4 plus 1. Oh, -1/8, 3/4 plus 1. Oh, I don't know if I can. -1/8 minus 6/8 plus 8/8. Am I doing right with my fractions? 7, it is 1/8. Please tell me if I am right, because I could make some arithmetic. Okay, 4. 4 cubed, 3 times 4 squared plus 1. 64. 16 times 3, 48 plus 1. 16, 17. This is 17. Oh, definitely bigger than 1/8. But we also need a critical points. Let's find the critical points. We need the derivative. Okay, 3x squared minus 6x. And this is just, this derivative is always defined. Then we will only need the zeros. Yeah, we don't even have to set up derivative is undefined because it's no fraction. Derivative is 0. If this expression is 0, I can factor out, I just factor out 3x. 3x equals to 0, or x minus 2 equals to 0. X is 0 and x is 2. Perfect. 0 and 2 are the critical points. Critical points, critical numbers. One thing is important. We always have to check if these points are placed in the given interval, because this given interval is the domain at this moment. Okay, and actually 0 is in that interval and 2 is in this interval. Sometimes we have the situation that one of the number is not. Okay, 0 and 2. Let's do the arithmetic. If we substitute 0, 0, 0 plus 1, it's equal to 1. If we substitute 2, 2 cubed minus 3, 2 to the power of 2 plus 1. 8 minus 4, 12 plus 1. Negative 3. Please correct me if I am wrong. Doing arithmetic in public, it's the most difficult part. Negative 4, negative 3. Okay, which one is the absolutely highest point, highest value?
17.
17, yes, of course. Absolute max. And, of course, absolute.
Negative 3 is the minimum.
Minimum. That's, we can see. Nice.
I have a question.
Yes, please, of course.
I missed what you did on when you did the derivative. How did you get to the 0?
Oh, okay, like this one?
Yeah.
Because we're looking for the critical points. This is the procedure to find the critical.
So if f prime of x is 0, then it has critical points.
Yes. Oh, yes, yes, yes. Oh, yeah. Okay, I have to come back. Okay, do you remember this? Derivative is 0.
Yes, okay. Yes.
Yeah, no. I mean, I'm glad that you asked. Where is my definition even? No, it's, where is the definition? Oh, okay. Let me, I can't remove it because, okay, this is, for the critical numbers, we always have to say derivative is 0, then we can find them, or derivative is undefined. Always. And what I did say that we don't have to consider derivative is undefined because was nice simple formula.
Yeah.
That's mean I only focus on this one. Yes. No. Good. Because if we will miss this, then you can see always the same steps. You can see here, I did derivative 0, derivative undefined. I didn't solve this one because too many. Derivative 0, derivative undefined. Okay. Yes, derivative 0 for the critical numbers. Okay, what else we have? We're doing quite okay. Oh, and actually, 0 and let's see, I have the graph. Yes, 417 max and 2. We didn't compute. No, that's correct. Negative 3. For some reason, I thought that is, and this is absolute minimum. And yes, 2 was a critical number. 4 was an endpoint. Okay, what else I have? That's the same question. You can try to follow this. Do we have time? We can do this one because this one is multiple choice and we know sometimes we have some. Let's solve this one, but I can just, perfect. The last question. Because I'm always, we always trying to perfectly check the concept. Okay, we have function x cubed plus 4x squared minus 3x. Find the absolute minimum m and absolute maximum, the capital M, of the function on the given interval from -2 to 1. This is our domain. Everything has to be here. Okay, first of all, we will need the value at -2. We will need the value at 1. That's the endpoints and the potential critical numbers. Okay, let's find them. How can we find critical numbers? Critical numbers. Let's use this. We need derivative, right? And since this is just the polynomial, derivative is defined everywhere. We just need to solve this. Yeah. Derivative is like not undefined. It's defined everywhere on the domain. Okay, derivative 3x squared plus 8x minus 3. Oh, quadratic function. Would be nice to factor out. Hopefully we can factor out because we need this derivative to be 0. 3, the factors of 3 is 3 and 1. 3 times 3 is 9. 9x plus 9x minus 1x will give us 8x. And I hope I did negative 3. Okay. 3x minus 1 equals to 0, or the other factor equals to 0. This is 1/3, and this is negative 3. And now, please be extremely careful. We have to check that's definitely critical numbers if we will consider the entire domain. But what is our domain? Which number we will not use? Is this number?
-3.
Yes, we will not use this one. It's not in the domain. This one, yes. This one, 1/3 is between -2 and 1. Let me do this way. Doesn't belongs to this. We will not use this. Okay, that's we only have. Actually, we will not do this. I will just substitute. I can even use it. Just 1/3. And I'm sure some of the values on this multiple choice options came from -3. Okay, please remember that will be okay, exclamation. Yeah, do not use the number if it's not in that interval. Okay, ready to finalize the session with some arithmetic? We will always use the original function. -2 cubed is -8. 4 times 4, 16. You may check. -3 times -2, +6. 14.
Yeah.
Okay. Yeah, 14. We see 14. Okay, 1. Oh, 1 will be easy. 1 plus 4 minus 3. 2.
Yes.
Okay. And 1/3. Oh, no. Cube. 3 cubed is 27. 3 squared is 9. And 3 times 1/3 is 1. What we can do, 1, 27, 27, 12, and 27/27, common denominator. Definitely the denominator is 27. 1 plus 12 minus 27. Who can help me? 14, -14. 27 minus 12 is 15. -15 plus 1, -14. Okay. Let me erase this just not to be confused what I am doing. Okay, which one is the lowest number?
-14/27.
Yes, this will be M, and of course, this will be the capital M. Do we even have that option? Because sometimes I'm getting excited to create the wrong options and I forgot to put the correct one.